Hello all, so let's try to do some Python hands-on on MP Neuron. So as discussed in lecture number 1 about MP Neuron, it's a very basic classification model as we all know, and it's not used in real life, but it's good to go to learn about machine learning and deep learning. So let's do some hands-on. So right now I'm using a standard data set of real life which is available from sklearn library, and for those who don't know, sklearn is a scikit-learn library for machine learning algorithms, and also it has some data sets that are standard for learning purposes. So I'm just using sklearn.datasets, and I'm also using numpy as np for future purposes. So first step first, that we are going to load the data set. So I'm just loading the data set using sklearn.dataset, as you can see, and load breast cancer. So it will load the breast cancer data set into the variable breast cancer. And now what I'm doing is, with breast cancer, I'm saving the data into X and target into Y. So target is to classify whether for the given data whether we have a breast cancer or not. So either it will be yes or no, and or in mathematical terms it will be either 0 or 1. We will see what is 0, whether 0 is having breast cancer or 1 is having breast cancer. We will see that. But firstly, let's load all the data set. Now if you might wonder how this x and y looks like, then if I'll print them, they will look something like this. So doesn't make sense, right? X doesn't make sense at all, but y somehow makes sense. So this is y, right? Just zeros and ones. So as I said, we don't know right now that whether 0 is having breast cancer or 1 is having breast cancer, but we can see that here we are having y as either yes or no, or 0 or 1 in mathematical terms. Or if you want to see x and y, like just I am writing x and running the cell, it will be an array. So you can see that it's an array, so there must be some shape of x and also shape of y, right? So let's see what are the shape of both x and y. So if you will print just x dot shape and y dot shape, you are getting 569 comma 30. So it's like we have 569 rows, so we have data of 569 patients, and we have 30 features. So this might be hard to visualize, so let me just try to put one new cell, and let's convert this into a data frame, like a pandas data frame or an excel sheet for you, for whom those who don't know about the pandas. So let's convert into data frame to visualize how the things looks like. So let me have some additional cells now, and what we are doing is to put this into a pandas data frame. So for that purpose I will need pandas library, so I'm just writing import pandas as pd, and now I'm storing this into just a data. So let's say I'm just converting. It's okay if you don't know about this thing, I'm just doing for visualization purpose that what this data set actually looks like in form of excel sheet for those who can't visualize that. So I'm just trying to use pandas for that, and so breast cancer dot data that we are going to use, and for the columns of my excel sheet or the data frame to be precise, I'm just using all those feature names. So best part about scikit-learn library is that we just have to call all this like basic names of English, and we will get all the data. So I'm just storing it in the data. Oh, there is some key error, maybe there is some feature, something about features. Okay, it's just feature, I guess, and now it's gonna work. Okay, perfect. Now let's try to see what data looks like. So if you will see, you can see that for, as I said, we have 569 rows, so you can see from 0 to 568. So in total we have 569 rows and 30 columns, and you can see there's a mean radius, mean texture, and so on. So and so on, we have 30 columns, and for each column we have a target. That is, if you can see here, the first is 0. Now what 0 indicates, we don't know that. So as of now we can say that for first row, that is this one, the our target is, or the output is 0, whether let's say 0 is cancerous right now. So let's see first that whether 0 is cancerous or 0 is not cancerous. So for that as well, there is a simple function that you can call. So we already have breast cancer now, so we just write breast cancer It's okay if you don't know all this, you will get it through as you practice. So I'm just saying target, and I'll just call names, and we will get the target names. So as you can see, 0 is malignant and this is benign, 1 is benign. So 0 is cancerous and 1 is not cancerous. So for those who don't know, malignant is cancerous and benign is not cancerous. Okay, so this is 0 and this belongs to 1, right? So for now what we can say that for row number 0, our output is 0 here. Let's try to add one more column, that will be better rather than going back and forth. So let's try to do that. So what I am going to do right now is simply add in the data. So right now we have stored our pandas data frame, that is our Excel sheet in common terms, in the data variable. So what I'm doing is I'm just simply adding a class or target, whatever you can say, right? And what we are doing, we are just simply adding the column. So what column of our target? So we are just using breast cancer, sorry, oh, and dot target. Now if I'll print my data, then we will be having one extra column called target. So you can see now there is, sorry, class, we called it class. So you can see it has class 0, class 1 and so on based on corresponding column. So we can say that if my features of the patient, this is some patient's data, so if my features are like this, then it will be class 0, which is malignant, that is cancerous, and class 1, which is benign, which is not cancerous, and so on. So this is how we visualize things using pandas data frame rather than this, like, because this doesn't make much sense. If I'll show you that this is my data, which is just some metrics of 569 cross 30, then it doesn't make sense, right? But this makes sense, like what are radius and concave point. These are all biological terms that we don't want to know. The only thing we have to know is malignant and benign, that is 0 or 1, right? So this is our data set, and as we all know that we have to do a train test split for accuracy, that whether we, after implementing our MP neuron, we will firstly train our model on trained data set, that is MP neuron. Right now our model is MP neuron, and we will test our trained MP neuron on the test data set. So for that purpose we need a train test split, right? So this was just for visualization, the pandas data frame thing, but let's continue from here now. So as we can see that here I'm just importing again using the sklearn scikit-learn library dot model selection. There is a function called train test split for the splitting the data set. So now what I am gonna do is our x and y were already right here, right? What we did, our data was stored in x and our target was stored in y. So I'm gonna use again x and y. As I said, the pandas thing was just for visualization, that how the data set looks like from the built-in sklearn library. So simply there is a function. So firstly what we need a training data set, right? So x train we also need x test, right? Similarly we also need the targets, what are our y. So here I am denoting y as targets, that is our class 0 or 1 or malignant or benign, and x is all the frame, all the features, right? That is mean, compactness and so on, from all these 30 features that we have. Here it shows 31 now because we have added our extra class here, that is extra column here, it's class, right? But currently we are just having 30 features. And again we also need y test. So this order is important in order to utilize this sklearn train test split function. So what we have to do, we have to simply call train test split, and we are just passing our x and y, and this will divide our data x and y into some split, and by default the split is 80% into train and 20% into test. But we can also specify based on simple, I think, argument here, which is called test size. So let's do it in a separate cell. So firstly let's see the shape now after the division. So you can see that original the shape of total y was 569, but now it's divided into 428, 426 and 143, right? Now as I said, let's try to do this come on. Okay, so let's try to have some test size. Sorry, as let's say I am doing 90 and 10% split, so 0.1 means 10% will be our test data set. So let's try to do that, and now let's try to print the shapes again. So now it will be, as you can see, the numbers change now from it's 80-20, now it's 90 and 10%, right? So this is how we use our train test split function. Now one more thing is that if let me try to print something called, let me call first print, and what I'm doing is, as we all know that our y is just zeros and ones, right? So right now what I'm trying to do is to see how many data points or how many patients that we have in our data set are having zero class or are malignant or cancerous, and how many are non-cancerous, right? Because in our data set it should be balanced in order to train nicely the model in future. What we must have is our data set should be balanced. Balanced means that there should be a same proportion more or less for class 0 and class 1. That is, model will be able to learn from both malignant as well as benign, right? It's not like our data set is just having all the cancerous patients. Then model will not be able to learn what are the features of non-cancerous patients, right? Make sense? So for that purpose I'm writing this line, so just bear with me for a moment, and I'm just trying to show some statistics about the data set that we have imported from the inbuilt library. And we know that since it's zeros and one, I'm just computing the mean, right? So if you will see, I'm getting in the entire data set, right, we have the averages of zeros and ones is calculated as 62, right? But when we do trend test split, you can see that we are getting in training data set, we are getting 61% from zeros and ones. So it's, we can say that one is more, right? Because the average is about 50%. And for test it's 0.73, so it's not balanced, right? Because somehow we need, and if I'll do this again, so if I'll do this train test split again, right, the split will be the same, but this numbers will change a little bit. You can see previously it was 0.73, now it's 0.61. It's more or less the same. So every time I run this, there is, sorry, I accidentally did while running, oh, not again. So again if I'll run, then there will be a different proportion. You can see now it's 0.64, 0.62 and so on. So why is this happening, right? So there are two things that we have to take care. Firstly, we have to generate the same output again, right? So since we are doing randomly a splitting here, we have to specify something that produce the same proportion again. If I'll run after 10 days this code, I need the same proportion or the same split of the data set, right? It's not like, right, today I'm training the model on some different data points and then randomly splitting again some other data points, right? So for that purpose there is something called stratification. So what we have to do, we have to stratify, and we have to stratify based on y, that is on the classes, that is y's are zeros and one. So what this will do is this will have the same proportion of the classes, that is malignant and benign or zeros and ones, equally in both training as well as testing, because our test data set should also resemble to our training data set, and they both should resemble to our statistics of the original data, right, that we have, so that we have perfect training as well as we have perfect testing, right? So now if I will print this, and also let me specify the random seed now. So I think it's random state if I'm not wrong, and we can give any number, but this number should be fixed for reproducing the same split again, right? So now let me print this item again, and now you can see it's more or less the same. In the original data set the mean is 0.62, even in the training it's 0.62, and in also in it's around 0.62, right? So while by using this stratify, we are balancing our training as well as test data set nicely, so that our training can be done on both in the same proportion, right, on both malignant as well as benign classes, so that model can learn what are the features of cancerous patient and what are the features of non-cancerous patients. And this random state is just to reproduce the result. So if I'll split this again, like run this cell again, then again we will be having the exact same figures. You can see if I'll run again for your clarity, then we will get exact same numbers again. It's not like we are getting different number altogether. So this is how we are going to split our data set in future. This is how the stratification works. That's why it's called stratification, that we have the same proportion of the classes that we are classifying in both training as well as testing, as well as in the same as in our original data set, so that there is a good data quality that we have for training as well as testing. So I think the video is quite a bit bigger, so I'll end here and I'll continue to train and code for MP neuron, and we will classify based on MP neuron, and we'll see how MP neuron performs on this basic classification problem. So thank you, and we will see each other on the other side.